Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yakoob. So now this is lecture number 5 of this foundation course, and my main focus is on mensuration. So mensuration, what is it about? Mensuration could be of two types. It could be 2D mensuration. It could be 3D mensuration. If it's about 2D, it's about perimeter and it's about area. And we could be talking about a circle. We can be talking about arcs and sectors, which we talked about last time. We could be talking about different kinds of quadrilaterals. It could be a square. It could be a rectangle. It could be a parallelogram. It could be a rhombus. It could be a trapezium. It could be a kite. And technically, we are talking about perimeter and area of all these figures. When we talk about 3D mensuration, we talk about volume of that 3D object. So this is technically an object. And 2D is technically a shape. That is the difference. So now if it's an object, we can talk about volume and we can talk about surface area. And then we can talk about cube, cuboid, prism. We could talk about cylinder. We can talk about pyramid. We can talk about sphere. We can talk about hemisphere. And of course, some composite shape, a combination of two or more shapes. So this is everything in this respect is about volume and surface area. Now, this is about O-level maths, or it's about IGCSE maths. There is very little difference between the two. So this knowledge is now used in pure math, P1, AS level math. And pure math P1 is technically paper 1 of the syllabus 9709. Now, what kind of questions can they ask? They can use these formulas and they can use algebraic manipulation. What does it mean? It means that, let's say, just to give you a simple example, I have two equations, x plus y is equals to 20. And I have the other equation, that is 10 plus 5, xy is equals to 50. And there could be a simultaneous equation thing. Or let me remove this 50, hold for a second. And let me just erase this 50 and let me call it another variable z. And if I ask you, express z in terms of x. So that means I want to get rid of y. How can I get rid of y? I can make y the subject of equation from any one of the two equations. So first of all, let me again get the eraser and let me use a black marker over here. So what I can do is that I can make y the subject from here. So this is equation 1. And from equation 1, make y the subject, that is 20 minus x. And now plug in equation 2. So xy is equals to z, or z is xy. Now we are removing y. So that is x 20 minus x. Yes, you can expand. That is 20x minus x square. That is z in terms of x only. Of course, constants do not count. We are talking about variable. Have a good look at this. So what I'm teaching you right now is that there are three variables. Some constant was given. And then what I did is that I wrote z in terms of x. Let me just write it over here in terms of x only. So is this method all clear? Just acknowledge it on the WhatsApp. Okay. Now, this is one thing. These are the kinds of questions that I'll show you. So now let's look at this question. This is an AS level maths question. That is the first thing you need to realize. This is a pure math P1 question. And let me solve it using the knowledge of O-level maths. So O-level knowledge is used for AS level maths. Of course, only the first part. Now the question says, let me highlight stuff. It says the diagram shows a plan for a rectangular park ABCD. So this is a rectangle 40 by 60. This is a park in which AB is 40 and AD is 60. Points X and Y. This is point X. This is point Y. They lie on BC and CD respectively. So this is BC and this is CD respectively. And there is a playground over here. So that's a playground right over here. That is a triangular playground. Now, before I read further, what do I see? I see a lot of triangles. That is the first triangle, that is the second triangle, that is the third triangle, the playground is the fourth triangle, and there is a rectangle over here. Now, I'll be working on this, and then it says show that the area of the playground is given by such and such. Now, let's go to the next page. Let's use a more colorful image. Now, first of all, if this thing is 40, because it's a rectangle, this is also 40. This is x. So how much is this? So this cy, that is 40 minus x. That's the first thing. Similarly, if this is 60, therefore this is also 60. This is 2x. So how much is bx? That is 60 minus 2x. That is 60 minus 2x. That is the second thing. So this is triangle 1, this is triangle 2, this is triangle 3, this is triangle 4, and there is a rectangle. So let me first work out each one. If I focus on triangle 1, so I'll write area of triangle 1, that is half into base, which is 60 minus 2x into height, which is 40. Let me simplify it. So 20 into 60, that is 1200, and 20 into 2 minus 4x, that is area of the first triangle. Let me focus on the second triangle. That is area of triangle 2. That is half into 2x into 40 minus x. And that is simply 40x minus x squared. The second is also done. Then I have this triangle, which is triangle 3. The dimensions are 60 in x. So area of triangle 3, that is half into 60 into x. That is 30x. So all these three triangles are done. And let me write area of the rectangle. That is 40 and 60. That is 40 by 60. 4 6 are 24. And then two zeros. That is this thing. And this is meter square. This thing is meter square. It's a good idea to write the unit. This is meter square. This is meter square. So now we are interested in area of the playground. So therefore, area of the playground, the fourth triangle, that is area of rectangle minus the sum of area 1 plus area 2 plus area 3. So therefore, this is area of the first square is 2400 minus area of 1. That is 1200 minus 4x. So minus 40x. That's not 4x. This is 40. Let me just correct myself over here. So it is the small thing minus this thing. So this is, let me grab a red marker, and this is 40. Two ones are, two 20s are, 22s are 40, and x. So 1200 minus 40x. That is 1200 minus 40x. That is the first one. The second one is 40x minus x squared. The second one is 40x minus x squared. That is this one. The third one in purple, that is 30x. Let's close the bracket and let's simplify. So now if I simplify, first of all, this thing is 40. So small silly mistakes. Let me correct myself. That is 40x. Black marker, this negative 40x, positive 40x cancels out. There is a minus over here, 2400 minus 1200. That is positive 1200. And then negative x squared becomes positive x squared, positive 30x becomes negative 30x, right in the proper order. First the x squared term, then the x term, then the constant term. And I have proven that yes, area is x squared minus 30x plus 1200. Area is x squared minus 30x plus 1200. I have obtained 2 mark. By the way, the P1 paper is 75 mark. So every single mark count. So that's how, using O-level knowledge, I have solved an AS level maths question right in front of you. Okay, so let's move on. Let's look at this question. Again, we are focusing on the first part only, just this first part. So now it says express y in terms of x, show that the total surface area of the block is given by. This time we are talking about a solid rectangular block, a base which measures 2x by x, the height of the block is y, and the volume of the block is 72. Let's see if you can handle this one. Let me pause the recording. So now over here, it says it's a rectangular block. Let's take a rectangular block, something like this. What are the measurements of this block? It's 2x by x and the height is y. So this is 2x by x. Let me highlight it. So this is like 2x. And let me make it thicker. So this one is 2x. And then this one is x. And this one is y. So now over here, this is 2x. This is not drawn to scale. This is 2x. This is x. This is y. That is a rectangular block. Now, the area of this thing, that is 2x squared. And if I want to find the area of this one, just playing around with the formulas, the area is xy. And the area of this orange face, that would be, this is 2x, this is y. So this area would be 2xy. And there are 6 such faces. So there is this top, then there is the bottom, which of course you can see. This is the right wall. There is a left wall over here. And then this is the front and there is the back. Keep that in mind. So it's a rectangular block and it has got 6 sides, 6 faces. Now they are saying the volume of this block is 72. So therefore, the volume is length into width into height. So this is length is 2x, width is x, height is y. This is 72. So therefore, 2x square y is 72. Therefore, 36 is x square y. This is equation number 1. Now it further says, show that the total surface area of the block is given by such and such. So now the total surface area, the front, that is 2xy. The back, that is 2xy. The right wall, that is this, which is xy. The left wall, that is also xy. The top, that is where it is, 2x into x, which is 2x square. The bottom, that is also 2x square. All good, all clear? So now let me just ask you people, all 6 faces, area, all good. So just acknowledge this thing on the WhatsApp, and then I can proceed with the working. So there are 6 faces because it's a solid block. If it was a box or something, the top would be missing, but we are not discussing that. And let me just check one thing, which is the recording. The recording is all good. So now if this is all good, that means the total surface area. So now the total surface area is 1, 2, 3, 4, 5, 6. So the total surface area should be 2xy plus 2xy. That is 2 times 2xy. That is 2 times xy. That is 2 times 2x square. Everything is taken care of. That is 2 plus 1, 3. So that is 6xy plus 4x square. That is the total surface area. But they don't want x. They want x over there. They are saying that the area is in terms of x only. So if it's in terms of x only, then what should I do? I should remove the y, that is 6x into y plus 4x square. Let me add a page over here. And what is y over here? So if I make y the subject, that is 36 over x square. So if I make y the subject, that is 36 over x square. So 6 into 36 is 216. So that is 216 divided by x. The x cancels out. Plus 4x square. That is the total surface area. QED. Quite easily done. Is this all good, all clear? Is the proof all good, all clear? Just acknowledge. Just have a good look at it. We started with this. We jotted everything down. So that is mensuration in AS level maths. What you have seen is an application of mensuration, which is the most fearsome chapter of O-level maths. I don't know for some reason. I'll make it, inshallah ta'ala, very simple. So that is how this thing is done. Others, please acknowledge. And that is one thing that I require from you, that once I am asking a question, just acknowledge it over there. All good, all clear? So let me share these 2 images with you. And hold for a second. Let me pause the recording. So now people, when I look at this question, it says the diagram shows an open container. So let me highlight things. Now it says it's an open container constructed out of 200 centimeter cube of cardboard. That means this is the surface area. The 2 vertical end pieces are isosceles triangle. So this one, that's an isosceles triangle. This one, that's an isosceles triangle. All good? And then, no, the 2 vertical pieces, yes, that thing is done. It has got 5x, 5x, 8x, that's all good. And the 2 side pieces. So now the 2 side pieces are this. This one is a, let me choose a different color. This one is a side piece that is the orange color, and this one is a side piece that is like the orange color. So there are two sides and front and back. They are rectangles and the length are y and 5x. So that is y over here and this thing 5x is over there. The open top is a horizontal rectangle. Open top. Show that y is this. Show that the volume is this. So again, this is a past paper P1 question. So we are using knowledge of O-level maths, and I'm focusing on this. How important is O-level maths? So let's look at this figure. This is a nicer figure. Now, what do I have? This that is 5xy. Area of 2, that is also 5xy. Now, what else do I need? This is isosceles. This is 5x, 5x. That means if I drop a perpendicular like this, then these two sides are equally divided. So this 8x actually becomes 4x and 4x. Now, there is Pythagoras theorem application over here. What is that application? If this is 5x, this is 4x, this height is h. This 5x is basically this. So, and this is a right angle triangle. So let me write over here, that is 5x the whole thing square, that is 4x the whole thing square plus h square. This is 25x square, this is 16x square, this is h square. Therefore, h square is 9x square. Therefore, h is square root of 9x square. And how much is that? That is 3x. Now, first tell me, is this working of height using Pythagoras? Just hold for a second. For a second. So now height is 3x. So now this thing is done. So is this all good, all clear? Yes, height. And is this all good, all clear? Okay, now this thing is all good. Now let me take this thing down. So now what do I need? I need the area of the triangle. So now the area of the triangle, that is half into base into height. Base is 4x, 4x, that is 8x, height is 3x. So that is half into 8x into 3x, that is 12x square. All good? Therefore, this is the front triangle, the triangle at the back. So this is front. This is triangle at the back. That is also 12x square. So therefore, the total surface area, the total surface area, that is equals to 5xy plus 5xy plus 12x square plus 12x square. How much is the total surface area? That is equals to 200. So therefore, this is 200 is equals to 10xy plus 24x square. Let's divide by 2. That is 100 is equals to 5xy plus 24x square. Let me add a page. So they are asking us to make y the subject. 100 minus 24x square is 5xy, and 100 minus 24x square over 5x is y. Is this the answer? 200 minus 24x square over 10x, I have simplified it. So if I don't simplify it, alternatively, let me choose this option. 200 minus 24x square. divided by 10x. That is y. That is what the examiner has asked for. So I leave the answer as it is. So is this proof all good, all clear, making y the subject? Acha ji. So I hope everyone got this. I think that is enough of the idea related to mensuration. And of course, we can talk about cylinders also. Let me just give you a brief highlight. In a cylinder, we know that this is the top, this is the curved surface area, and then over here, there is the bottom over here. So if I just highlight it like this, so there is this bottom area. Got the idea? So I have this thing that is the curved surface, and this is the bottom area. We know that the top has an area of pi r square. We know that the bottom has an area of pi r square. We know that curved surface area is 2 pi r h. So whether it's a closed cylinder or it's an open cylinder, there are few differences. The first thing is the volume is the same. That is pi r square h. This is the same in both. When we talk about the surface area, in a closed cylinder, the top is there. In an open cylinder, the top is missing. The curved surface area is there in both of them. Over here, curved is over here. The bottom is present in the closed, the bottom is present in the open. So the word closed and solid, it means the same thing. So what is the top area? Pi r square, it's not there. What is the curved surface area? 2 pi r h, 2 pi r h. What is the bottom area? Pi r square, pi r square. That means for the surface area of a closed cylinder, that is 2 pi r square plus 2 pi r h. A lot of people, they make a mistake in writing this. In a surface area of an open cylinder, there is only 1 pi r square. And still there is 2 pi r h. So just wanted to focus on this, that the difference in the surface area lies over here. That's where the difference lies, the between the top and the top. In the solid or closed, the top is there. In the open cylinder, the top is missing. That is why it's open from the top, open from any one side. And what about the volume? The volume is the same whether it's the closed cylinder or whether it's an open cylinder. So I just also told you a bit about the cylinder. One other thing I want to tell you about the cylinder is that when we have this thing, if I enroll the curved surface area, what happens? What happens is that this thing over here, let me make it thicker. This thing over here, that is the circumference. So this is the circumference of the circle. Radius r, the circumference is 2 pi r. And this thing over here is h. So that is how when we unroll it, and it forms a rectangle. So this is 2 pi r, this is h. So technically, that is what? That is the curved surface area of a cylinder. So I think let's stop our course, the foundation course, right over here, giving you a lot of insight about O-level maths, how it is used, and how you can have a smooth transition from O to AS level maths. Wish you all the best of luck for AS level maths and stay tuned for further updates. Take care, everyone.